Welcome to our session on group learning using the Common Core. Our goal would be that as teachers you'll be able to distinguish between cooperative and collaborative learning, and you'll be able to implement both in your classroom, and we would hope that this would support your students as they move through the Common Core curriculum. Obviously, we think that group learning has benefits for students. It allows them to work with all types of people and learn to get along with all types of people. They have opportunities to hear other people's opinions and reflect and respond to those opinions about mathematics. And the differing points of view help them to strengthen what they end up creating. They're actively involved and they have a stake in the end product, and they get personal feedback not only from the teacher but from fellow students. Although many of us use these terms interchangeably, there are differences between cooperative learning and collaborative learning. Basically, cooperative learning is when there's roles in the group, specific roles like recorder, timekeeper, group leader, those kinds of things, and one product is produced and everyone in the group gets the same grade for that product. You think of it like a group project. And then collaborative learning is when students work together in a group. They collaborate to accomplish a task, but each person is responsible for their own product and it's graded individually. So as we go through these activities, think about whether they're cooperative or collaborative. We call our first activity the apple pie activity, because at the end of the activity you can provide students with apple pie to measure and then enjoy. You're going to choose a number of cylindrical or round items, measure the circumference of each of these round items and record that. Trace the base, cut it out, fold it in half, and measure the resulting diameter. And of course record that. And then divide the circumference by the diameter. The goal of this is to give us pi. This is the handout we have created for the activity. The students would put the name of the object in the first column, measure the distance around, or the circumference, in the second column, and a distance across the middle of the object, or the diameter, in the third column, and then divide the distance around, the circumference, by the distance across, the diameter, to get a number in the last column. The bottom of the form has the students noticing that the numbers in the last column are about 3 point something and taking an average of those, which you'll talk about in groups and then talk about as a whole class. Here are some sample questions that could be used to debrief this activity. And again, the idea is for students to derive pi and to know where pi came from. The next activity is a whole class collaboration. They're questions about circumference, so we'll be using pi to answer some questions. Take a moment to read through this slide, and then I'll show you what the cards look like. The students are each passed a card. This is what each card looks like. On the right-hand side, there's a question. The students would say, some random student would read, who has the circumference when the radius equals 5 inches? Somebody else in the classroom would have on the left-hand side of their card the answer to that question, and they would pipe up with, I have 31.4 inches, which is the answer to the previous question. And then that same student would read their question, who has the circumference when the diameter equals 3 inches? The student in the room who has this card would yell out, I have 9.42 inches, and who has the circumference when the radius equals 2 feet. And then this activity continues on and on until all the students have read their cards. The first student who read that first clue will have the answer to the question that the last student reads. A complete set of cards is provided in Google Docs under this presentation. And you can use this for circumference, or you can use the idea to modify it for anything in your classroom that you want kids to really know. this works really well because students will have to do a lot of problems that involve circumference. You can either have students stand up and make a circle around the room as they read their cards, or stay at their seats and do each problem and then turn in the paper at the end of the period. One way to get students to use academic vocabulary is to have them work with an elbow partner and use a sheet such as this. The partner on the left writes a problem and becomes the teacher. The partner on the right listens while the partner on the left teaches and keeps track of vocabulary that is used and puts just a little tally mark next to each of the words below. So here's a possible question you could use for the last activity. The student on the left would be teaching the student on the right how to get the circumference of a circle with a radius of 5 centimeters. And as they say words like radius, diameter, circumference, and pi, the student on the right would be putting check marks or tally marks next to those words. The next activity we have works a lot like the I have, who has activity, except that kids work in groups of 4 and have cards in an envelope that they pass out. The question on the right and the answers are on the left. This is done the same way, just at a table, laying the cards down like dominoes. So they can start with any card, and this is an example of what the cards look like. And you want to answer this question: the area of a circle with a radius of 2 centimeters. And then all the students look through their cards that they have in their hand and find the answer that's in the circle that matches this question. Then they would lay the domino with the answer of 12.56 centimeters squared next to the first domino, and just keep going until they got to the last domino, which should have the question and the last domino match the answer on the first domino. And again, a complete set of dominoes is available online in our session. Here's a question you could use for the vocabulary tally for this example. Students would explain how to do the area of a circle with a radius of 10 yards, and then the student on the right would check off things like radius, squaring, and area. Another use of pi, of course, is to find the volume of anything that's shaped in a round manner. And the volume of a cylinder has the formula of the height times pi r squared. We found a video on YouTube showing the volume of a cone from the volume of a cylinder. So you would click on this link to show the video in your classroom, or just to see how the teacher in that video does it. Basically, he takes a cylinder and a cone with the same diameter and the same height and shows that you would fill 3 cones from the cylinder. He uses popcorn, and you could build these out of plastic like he did, or you could just show the video in your classroom and derive the formula for the volume of a cone, which is 1/3 of the height times pi times r squared. So check out the video and you can see how this teacher does it. Okay, if you had been in our presentation, you would have seen us work as a whole group on the idea of why do we work in groups. So that was very collaborative. So we would come to the idea that we collaborated on that to decide why we would work in groups in a classroom. The apple pie activity is more cooperative because there are roles, everybody does a certain part, you come up with this paper where everyone comes up with pie, so it is more cooperative. The circumference activity, I have, who has, can be cooperative or collaborative. It would be cooperative if we all stood up in a circle and made a big circle around the room. It would be collaborative if each student did all the problems on their own paper and turned that into the teacher. The same with the area dominoes. It's more collaborative because each student would work on their own paper and turn those into the teachers while they collaborated on making this circle of dominoes on their table. The cone activity from a cylinder could be cooperative or collaborative depending on how the teacher handled it. If you are just showing the video and then talking about it, it's more collaborative. If you have groups of kids working together to produce the formula themselves, it's more cooperative. And then the vocabulary tally probably is more collaborative because students are looking at each other's work and listening to each other's vocabulary and collaborating on using as much academic language as they can. Obviously, in the Common Core, we have these standards for mathematical practice. If you look at the first 6 of them, you can see that working in groups or working with other students covers very many of them. Because we make sense of problems and we persevere in solving them when we're working together, we have to reason together, we have to argue together and critique each other's reasoning. We might use modeling like we did with the cones, and that would be an appropriate tool. And of course, if we're doing lots of problems on circumference and lots of problems on area, we would have to attend to the precision of those calculations to make those games work. Thank you very much for looking in on our presentation, and we hope that this was helpful for you.